HVAC 360, episode number 8. My interview with Gordon Holness, ASHRAE President, 2009-2010. Welcome to another episode of HVAC 360. I'm your host, Matt Nelson. This week I had the great opportunity to catch up with the ASHRAE President, Gordon Holness. Gordon's the President of American Society of Heating, Refrigeration, and Air Conditioning Engineers. ASHRAE does a great job in developing standards around the country, and I know that throughout this interview you'll get an opportunity to kind of understand a little bit about what they do, some of the new things that are coming out with, and a little bit of background and history as far as some of the other standards. So I won't say too much, and we'll get on with the interview with Gordon Holness. Hi, I'm here talking with Gordon Holness, who is the 2009-2010 President of the American Society of Heating, Refrigeration, and Air Conditioning Engineers, also known as ASHRAE. How are you doing, Gordon?
I'm doing just fine. Good to see you this morning.
Well, thanks for taking your time out of your busy schedule to take a moment and talk with us. So, can you describe to me what really the purpose of ASHRAE is?
ASHRAE is a society that has an overall mission to advance the arts and sciences of heating, refrigeration, and air conditioning engineering for the benefit of mankind and to promote a sustainable world. And today the big emphasis is on green buildings and sustainable buildings so that we have a place for our future, for our children's future.
So what do you think most people don't know about ASHRAE?
They don't fundamentally know who ASHRAE is or what we do. Because we are, if you like, the quiet society that's behind the technology that provides the comfort conditions in their homes and their offices. We're not out there as engineers sort of promoting ourselves. We're out there really just developing the technology to improve energy efficiency and comfort conditions in buildings.
So, I mean, that would be the primary difference between us and other organizations, you think?
We don't market ourselves very well. That's probably one of our greatest faults. I think we do an incredible job in developing the codes and standards that go into building development. You cannot build a building in the United States today without following one of ASHRAE's standards, whether it's Standard 90.1, dealing with the energy efficiency of buildings, or whether it's Standard 62.1, dealing with indoor air quality. All those are built into the building codes. We sort of take those for granted, but ASHRAE is constantly developing and improving those to improve the environment.
So not only has ASHRAE developed a number of codes or standards that have been turned into codes, they also have certification programs now. That's something that's been rather recent in the last couple of years.
That is absolutely true. We've always had a very good range of educational programs for our members and for people outside the industry. And those educational programs are offered anywhere from conventional seminars and courses to self-directed learning and even e-learning, which is on-demand, online educational programs. But now we've expanded that further to provide certification, which is really validating the qualifications of people in various aspects of the industry today, because we think that's important as we move forward.
So now, who are the members? I mean, ASHRAE is comprised of different types of people. What sort of walks of life belong to ASHRAE?
Actually, we're a very diversified organization. I think people think of us as an organization of engineers, but in point of fact, consulting engineers as such probably make up only about 1/3 of our overall membership. We have people from the industry, whether they are contractors, whether they are vendors, whether they are manufacturers' representatives in different fields. We have a lot of people from manufacturing industries, great support from the industry. A lot of educators, a lot of schools and universities. A lot of governmental agencies have members in our society. just a very diverse group, actually.
Now, what about students? How do students integrate into what ASHRAE does?
Well, students are the lifeblood of our society, and I mean that both in terms of our society as ASHRAE as well as the society overall. They are the future, and so we work very hard to encourage students to enter the engineering field and to enter specifically our field of HVAC and our engineering. And so we have probably about 4,500 students around the globe. And we encourage student branches and work with the faculty to, as I say, encourage those students to enter our industry.
And that's mostly at the university level. Though when you talk about students, you talk about people, attending college or university.
No, actually, we go much further than that. Today, we very much try and talk to students in the high school level to get them to enter university into engineering programs. Because there is a dearth of students that are entering engineering in the United States, and we need to encourage more to do that. So it really starts at the high school level with some of our student activity programs, and then moves on from there into following them through their university programs and encouraging them through scholarships and through competitions and other activities to stay involved.
So let's talk a little bit about being an ASHRAE president. What is that? I mean, I guess what's the process of becoming an ASHRAE president?
It's a combination of many years of involvement in the society. You really have to know how the society works as an organization. I've been a member of ASHRAE for 45 years. I've been active in society level activities for probably 28 years. So I've served through many of the committees, as chair of many of those, through the councils, and attended many of the technical committees that we have. It's a very diverse organization. We have about 110 technical committees addressing many of the different aspects of our industry's technology. We have standards writing groups and committees, probably about 95 of those at this point in time, as well as a basic structural organization. We probably have about 2,500 active members who participate at the society level in these committees. And so, working with them, getting a feel for them, so it gives you the background, if you like, to represent that society as you move forward. I came onto the board about 8 years ago and served on the board of directors as the director at large for 3 years, and then moved on to become a vice president, and ultimately treasurer, president-elect, and president. Mm-hmm. But it is that background that gives you that knowledge base to understand how we work with other organizations, how we work with government agencies, Department of Energy and others. And you have to build up that in order to properly represent the society. You have to understand sort of how all these relationships do work.
So what made you want to be president? I guess what made you choose this path of because it's obviously it's a job that involves a lot of travel. It's very stressful at times, So I guess why'd you do it?
Well, that's an interesting question. I've been involved in the society for a long time, and the value to me in my career over those years has been the peer-to-peer relationships. It is no other industry in the world that I know of has that depth of expertise just available on tap to you. So if in my career, for example, I was designing a new thermal storage system for a major project, I could go into that particular committee and just talk to people who are the experts in the world in that field and explain to them what I'm trying to do, and they just freely share that type of information. When you've gone through that for all those years and sort of seen that type of giving, that type of support, you also want to give back. And so when I started winding down my professional career, I really wanted to stay involved. I wanted to sort of give back some of my knowledge, some of my things I've learned over the years back to the society and back to our members. And so that's really why I got back involved.
So everybody has a presidential theme. What is your presidential theme?
I chose a presidential theme that is sustaining our future by rebuilding our past. because I do strongly believe that energy efficiency in existing buildings is our greatest opportunity for a sustainable future. If you look at our industry and look at the built environment that's going on and look like 25 and 30 years ahead, we have to recognize that 75 to 80% of the buildings that will exist 25 years from now exist today. And so if we can have a material impact in terms of comfort and energy efficiency and indoor air quality, it's going to be by addressing the existing building stock. And so that's why I chose my theme for this year.
So what do you hope to accomplish through your presidency?
Well, I hope to accomplish several things.
Okay.
That's a wide open question. We are a global society. We are growing probably more rapidly outside the United States than we are even internally. And so part of my objective was to expand that global reach, because we can learn a lot from what the industry is doing around the globe. Technology is not always here in the United States. We can learn a lot from what Europe is doing under their European Building Performance Directive to improve the indoor environment there. And so one of my major goals was to expand our reach, expand our relationship with our associate societies. We actually have about 52 associate societies, which are similar organizations to ourselves in different countries around the globe. And so part of my intent was to expand that reach, expand those relationships, and continue to develop those. The other thing, of course, I really wanted to do was to carry my theme forward into a constructive long-range program for the society. And so we have built up many resources as a result, new standards, new programs, so just new guidelines and directions for the society that gives us an overall cohesive program for energy efficiency in existing buildings.
So what do you find most difficult about your post?
Probably the time constraints. It is more than a full-time job. I probably spend 55, 60 hours a week doing that. Just the challenges. They are not only the day-to-day ongoing activities that occur in running what is really a business of about $20 million a year with 52,000 members, but also to reach out. I'm constantly on the road, traveling to different student branches, our chapters, attending conferences, as well as, say, traveling globally. And so the time is probably the biggest challenge that comes to you. But I certainly have enjoyed it. I look forward to completing my year and then moving on from there.
So during your presidency, I guess, what have been some of the happy surprises that you didn't really expect coming into it? What are some of the benefits and some of the things that came along with the post that surprised you?
Well, I've always understood the passion of ASHRAE members and how really involved and giving they are in this industry. But you don't realize how widespread that is until you start traveling internationally. ASHRAE is a highly recognized and tremendously respected organization around the globe, and I guess the extent of that really sort of surprised me as I toured around. I expect to have to explain sort of who ASHRAE is and what we do. Instead of that, they're very much aware of us ourselves as an organization, about the leadership we provide in terms of the industry. And so there is a tremendous recognition and respect out there. So that really was probably the most pleasant surprise as I moved around.
So what was probably the most exotic place that you've seen in your travels?
Well, people think that traveling around is exotic, and it can be. But when you're traveling for business, this is what it is a business. You find yourself on incredibly tight time schedules, and so you get to know airports very well, not necessarily to know communities very well. I certainly enjoyed Bangkok in Thailand. That was very enjoyable. I certainly enjoyed the opportunity to see the Taj Mahal in India. I probably one of the nicest cities I visited was Hong Kong. Just a very incredibly intense community and very much leading in many respects in our industry. But fundamentally, I just love Europe. I mean, Europe is just got that tremendous culture, that heritage that is really unique. And so the opportunity to travel through Europe, particularly to travel to places like Rome and Berlin, have been very enjoyable and rewarding.
Now, your background is rather unique. You were born and grew up in the United Kingdom.
That's correct.
And you traveled to Canada and then the United States. But really, you've practiced engineering in 3 different countries. At least I say.
Yes,
at least you based yourself in 3 different countries.
That's correct.
Can you tell me a little bit about what is there much difference in engineering between the different countries with codes and things like that, or is it something different?
There is a commonality to engineering around the globe. No, the fundamentals exist. Probably one could argue that the codes are more rigid in Europe than they are in North America. We have a sort of much more open society in the United States than we necessarily see in other places. Probably the biggest difference for me as a practicing engineer is, however, that in England and in Canada, I mostly work for mechanical electrical consulting engineers, whereas in the United States I work for an architectural engineering integrated practice. And there's a big difference between the two. When you work for independent mechanical engineers, for example, you are hired by an architect to work with them. That's a different relationship than working with an integrated firm. And there are advantages both ways, but I certainly have enjoyed the opportunity to work in a firm the size that I work for, because it did give me access and opportunity to project types that otherwise could not occur.
Mm-hmm. So what got you involved in engineering in the first place? I mean, did you grow up wanting to be an engineer? What kind of steered you in that direction, I guess?
That's one of those peculiarities of life, just pure chance. I graduated from high school before I was 16, and my family was not necessarily that well off, so I had to go out and earn a living. And so in looking around, I found myself working for the local county council. And it turned out it was the architectural department, the engineering sub-department. And so, it gave me a job. But very soon I found that it was a job that I had a great interest in and thought there was a great future in. Having done that, I decided I better get an education. And so I moved from a small rural area in southern England up into London so I could go to night school. And then for the following 7 years, I went to night school while working for consulting engineers in London. That's how the whole thing started. It was really sort of by chance, but I chanced to find an industry I just love to work in, and I've had a career that I have enjoyed as well as being able to make a good living.
Yeah. So now in England, I guess we have ASHRAE in the United States. In England, they have the Chartered Institute of Building Science Engineers. Is that right?
Building Services Engineers.
Building Services Engineers.
That is correct. Yes, there are parallel organizations to ASHRAE, and I think part of what I have enjoyed is that we have developed these relationships between these organizations that work very cooperatively together. I became a member of CIBSE as I grew up and worked in London, and so carried that membership across when I came into Canada. But that's where I found out, of course, that ASHRAE was the predominant organization for our industry in North America, and so that's when I became an ASHRAE member 45 years ago. So.
Now, what, I guess, I remember getting a like a press release or something of that, being some sort of reciprocity between ASHRAE and SIBC. Is that anything that you can expound upon about that? I mean, what are the... You could have like a dual membership almost?
I don't know whether that's really the case. The memberships are separately, but actually there is an ASHRAE SIBC group now that our members in the United Kingdom work very closely with SIBC members and share joint meetings. The engineering side is different. England has what is called chartered societies, and chartered societies are the equivalent of professional engineers. So while ASHRAE is an engineering society, our registration for engineering is separate through the National Society of Professional Engineers. In the United Kingdom, the Chartered Institute of Building Services Engineers is the professional society for that industry.
Now, I know that ASHRAE has, if most people know anything about ASHRAE, they know about the series of books that ASHRAE produces.
Yeah, handbooks.
The handbooks, the fundamentals, applications, things like that. Now, I know SIBC actually, the one thing that surprised me when I was at the HR, or the Orlando meeting, is that they actually had, in the bookstore, they had a set of SIBC handbooks as well. I found that very, very interesting. They were pretty detailed all throughout. It was interesting to see that kind of correlation. That they have their own set of handbooks that govern anything from maintenance and building operation to engineering applications.
Now, that is correct. Actually, SIBC, unlike many of the other similar societies around the globe, SIBC does have its own set of engineering handbooks that they have developed over the years, and they're very good. So we share publications. ASHRAE publications are posted and sold in the SIBC bookstore, and SIBC publications are sold in the ASHRAE bookstore. And we do have some joint publications that we have done together. We've also had some joint statements. For example, we have a joint statement on climate change that we've worked on together. So we have a great cooperative working relationship with them.
Now, as you've when you worked for Albert Kahn and Associates in Detroit, there was a number of award-winning projects. You've won a number of ASHRAE technology awards for projects that you've engineered. I guess what project can you point to as one of your favorite projects?
Probably the lead project in my mind was the University of Michigan Hospital. Not only because of its complexity, but also because of its size. It was designed in the early 1980s. It was a project of about 1.1 million square feet, including both patient areas as well as diagnostic and treatment areas. But as I said, a very complex program. And our target in designing that was to make it just obviously fundamentally responsive to the patient environment, but also energy efficient. And we set a target of an energy efficiency level that was essentially unheard of at that point in time, and were able to achieve that target. And so I decided to enter it into the ASHRAE Technology Awards program, and were fortunate enough to win not only at the local level, but all the way up to win first prize in the society for that.
Now, as far as projects go in general, obviously you've done a number of them over the years. What are some of the things that, as an engineer, you can identify problems early on, or things that tend to make the project go, say, south a little bit? That don't make it go so well. Is there anything in particular that you've seen projects like, when this starts to happen, it's all of a sudden it is a little bit harder to go through the engineering process?
The greatest problem I think we see in the industry is a very simple one, and it is simply communication. We tend to take the criteria from the owner and then sort of retreat into our offices and sort of design in a vacuum. and then turn around to the owner and say, here it is, and we think this is what you want, and now let's go ahead and build it. The most successful projects is A, when you have a knowledgeable owner, which helps, but B, when you have constant communication, open communication with the owner all the way through, so there are no surprises, no sort of unexpected issues that come up. Communication is, I think, a real key element to a successful project all the way through.
Now, when you talk to, if you're giving advice to younger engineers, people just starting out, what kind of advice might you give them, as far as, career-wise, as far as learning or some lessons learned that you could probably, pass down to them?
Talk to your peers. Talk to those with experience in the industry. This is an unusual industry. Everybody emphasizes, sort of, if you like, the technology, the engineering that goes into it. But we talk about the arts and sciences of HVAC and our engineering, because it is as much an art in terms of application of design as it is a science from the pure engineering, the pure numbers aspect. Having decided and calculated out what the heating or cooling load in a building is only the starting point. From that point on, you've got to select a system that can respond to those loads, meet those loads, but also respond to an owner's needs and their occupancy of that building, their use of that building. And that's where the art comes in. And so it's learning that art, learning that application that I think is really key to success. And the best way of doing that, as I said, is talking to those with that experience and those peers in the industry that you respect.
Now, what about people that are looking for a path, a career path, whether they be in college or otherwise? What's the best way to go about learning about HVAC? I mean, what advice could you give them about? Okay, here's a starting point. Possibly look at these two courses or volunteer. What sort of advice would you have people trying to break into the industry, so to speak?
Find a mentor. People in our industry are great sharers of knowledge and information, and you really, that's one of the reasons why we have student branches and why we have our chapters. It is provide a sort of a resource to young people coming into the industry, and we need to welcome them in. But you need to find people who have that experience, who have that knowledge, and can provide that guidance. Mentorship is I think, is probably an important piece of the pie as anything.
Now, let's switch gears there a little bit. Obviously, green is a big topic. Being energy efficient, that's ASHRAE's big push in the whole green movement. I think that would be one of our focal points is energy efficiency. Can you talk a little bit about how ASHRAE is responding to the green movement, how it's integrated into the whole process?
Well, ASHRAE's focus has always been HVAC in our systems and really sort of establishing the indoor environment in terms of how a building works, how it performs, how it meets the consumer's needs. But today we had to recognize that we had to deal with total building systems. It's not enough simply to deal with the mechanics, if you like, of equipment. We need to deal with the building as a whole. And so we've come to realize that building orientation, for example, has a big impact in terms of solar load on the one hand and the opportunities for daylighting on the other. And so integrated building design, total system design has become sort of fundamental to how we move forward. The whole green and sustainable building movement is, if you like, a basic change in American culture. We have, unfortunately, over the years become a rather wasteful society, a sort of rather throwaway society. So, for example, if you look at a construction site, the amount of waste material on a construction site is phenomenal, and it's unnecessary. If we plan right and design right and go through the whole construction process correctly, we can reduce all of that waste. We can reduce the impact on the environment we have in simply the construction of buildings. And so the whole basis of sustainability just starts fundamentally with the building as a whole, and then goes through the entire program of design, construction, and operation.
Now, you've been one of those pieces in ability to reduce waste is doing BIM modeling, building information modeling, and you've been a key player in ASHRAE as far as developing that goes. Can you talk a little bit about what building information modeling is and what benefits it can have?
Well, this industry started with simple drawings, pencil on linen, even ink on linen if you go back far enough. But basic drawings are in themselves fundamentally dumb documents. They're simply illustrations of a design. When you get into building information modeling, you're actually building intelligence into those drawings and specifications. When you do that, every single line you draw has a meaning, has an impact. And so a line, instead of simply being that sort of scribble on a piece of paper, that might be a 2-inch copper pipe. And you can put the intelligence into that 2-inch copper pipe and say it's a type M copper pipe, and it's carrying chilled water at 45 degrees and so many gallons a minute. There's an incredible opportunity in the building information model to build those levels of intelligence in that not only carries through the whole design process, but will get carried through into the construction process, into material ordering and supply, all the way into actual construction and into operation of the building. So that later on, maybe 20 years down the road, when you have to replace a piece of equipment, you can go back to that building information model, and the intelligence for that piece of equipment resides there, and you can simply use that as a basis of reordering. So it's a tremendous capability that this offers.
So as far as the industry goes, how is building information modeling kind of getting integrated? I mean, is it a slow process? How do you see it advancing?
It has been much slower than I had hoped, to be frank. It is complex, and we need easier to use tools than have existed along the way. Now, our company actually started using building information modeling as early as 1985, 86, and had done so very successfully on very large projects. But it is complicated, and it does take sophisticated software. It does take training and learning of your operators. It even takes training in terms of users. And one of the difficulties is how rapidly that software can be developed to be more user-friendly, and that's the biggest challenge. But I think the opportunities for that are incredible. The other aspect of it, of course, is that we need to recognize that our industry is very fragmented. Most design offices, whether they're architectural or engineering, are actually quite small. It's not unusual for an architectural office to be 3 to 5 people, and for an engineering office to maybe 5 to 10 people. It's very difficult for those very small offices to be able to handle the complex software for BIM modeling, as against larger offices. I was fortunate enough to work in an office that ended up, when I retired, of having 400 people. So you had a lot of resources in there, not only in terms of the engineering capability, but also in terms of computer technology that otherwise you couldn't have in a smaller office.
Talking about energy efficiency, the ultimate goal of energy efficiency is really to have the net zero building, what's called the net zero building. How is that going?
It's going very well. Net zero buildings, of course, are those that on an annual basis use no more energy from the utility grid than they put back into that grid through renewable energy sources. But the very first step along the way is to make the building itself as energy efficient as possible before you even start looking at putting in renewable energy sources, whether that be thermal, solar photovoltaic, or wind. And that's the challenge. How do you do that? And in the past, we might have viewed that as being simply making the HVAC&R equipment highly efficient. But it's much, much more than that today. You have to make the total building system as a whole energy efficient. That means the building envelope, the fenestration systems, the insulation levels, the lighting, the ventilation, as well as the HVAC&R systems. It's the collective whole that can get you to the point where you need to be.
Now, as far as obviously, when you make something, you're tweaking it, equipment that exists today, you're making it more and more efficient. At some point, you have to stop and say, you know what, maybe there's a better way to do this altogether, and not, instead of trying to improve a piece or a component or a system, to stop and say, okay, there's a different way of doing that. I mean, is there, I guess, information out there of different, people trying to, change how we look at heating and cooling a building?
Yes, there are. I mean, I think you're seeing really big changes in the selection of systems. Having achieved a highly efficient building envelope, having maximized the amount of daylighting you can get in, the control of lighting systems, now you start looking at what is the right system to apply to that is as energy efficient as possible. We used to think of those in terms of the traditional variable air volumes or constant volume reheat systems. But air itself is not necessarily an efficient transporter of energy, not compared to water or refrigerant. And so you're seeing a movement towards radiant heating and radiant cooling systems and dedicated outdoor air systems, smaller, more componentary systems that are much more efficient in themselves. By the way, they're also easier to operate and maintain.
Now, is there a lot of this comes, when we talk about net zero, people are like, you know what, we're going to stick with the status quo unless the government starts to change its policy and start mandating some of these things. I mean, is that something that's going to be, coming up in the future? I mean, obviously we're not, political and all, but it's what do you see, envision, coming down the pipe?
Well, we are after all a capitalist society, and I mean that in the nicest way. We're driven by the fundamentals of economics and how we live our lives and how we do business. Everything has a value and a relativity to it. We enjoy in the United States relatively cheap energy. We buy gasoline at $3 a gallon and complain about the cost. In Europe, they pay $9 a gallon. Similarly, our gas and electricity bills in the United States are much lower than they are in Europe by factors of 3.5 or 4 to 1. And so having enjoyed that cheap level of energy, it's been sort of easy to sort of just freely use it and not worry about the efficiency or the cost. Well, today we have to worry about it for two reasons. One, the availability of energy is diminishing, and so we can expect to see restrictions in regard to energy availability, which is security in itself. And two, I think we have the realization that our use of that energy does result in high levels of greenhouse gas emissions, particularly CO2, going into our atmosphere, which is in itself going to, on a long-term basis, affect our lives.
Now, as far as Europe being more advanced than us, because obviously they have different policies in place, and the costs are such that it really kind of forces them into being more energy efficient. How are they dealing with net zero?
They have a very aggressive program on both new and existing buildings. Under the European Building Performance Directive, they are making significant inroads to improve existing building performance. There's a lot of government incentives out there for that purpose. It's not unusual in many of the countries that are part of the Performance Directive for the government to pay up to 50% of the cost of retrofit of their existing building stock. Even on a local basis, you may get local communities spending another 30%, so the building owners only spend 20%. That's a tremendous incentive. And so you're seeing sort of radical changes there, driven, as you said, by high energy costs and also by limited availability. On new buildings, they've set the target of all new residential buildings being net zero by the year 2016. That's only 6 years from now. And for all new commercial buildings to be net zero by 2019. Those are very aggressive schedules. And so we're all working together looking at the technology to achieve those types of goals.
Now, where are some of those resources that people can, if they're looking at, what's being done already, so they're not, reinventing the wheel? What are some of the best sources of information for that?
You'll see a lot of that in terms of guidelines that are now being developed, and ASHRAE is working hard on a series of guidelines, including the Advanced Energy Design Guide series. But it's also in terms of the conferences that we hold around the globe, we as an industry, not just ASHRAE. There is a tremendous amount of information being shared out there throughout Europe and elsewhere. It's one of the reasons why I travel a great deal is attending these conferences and learning what is happening in these countries, what technologies are being successful, and some that are not necessarily successful. It's learning from each other, and there is a tremendous amount of information available.
Now, when we talk about energy efficiency, it's in the LEED process. A lot of emphasis, with new buildings have been in place with LEED or different energy efficiency standards, whether it be 90.1. But it was interesting to hear you speak about the existing building stock, and that really, when you talk about developing renewable energy, when you talk about improving the new buildings that are being built, it really, when it comes to energy usage and carbon footprint, your biggest target out there that people may not be looking at is the existing building stock that exists in the United States.
It is indeed. If you look at where construction dollars go, only 2% of construction dollars actually go into new building projects. 86% of construction dollars go into the retrofit of existing buildings. As I mentioned earlier, 75 to 80% of all buildings that will exist 25 years from now exist today. That is where the greatest opportunity is. It is also the greatest challenge. It's much more challenging, if you like, and sort of idealistic to start with a brand new building and sort of build up those systems from scratch to reach the goals. It's much harder when you start with existing buildings and look at retrofitting those. Harder from the standpoint of not only the technology, but also the economics and also the incentives from a building owner's standpoint. It's a change in mindset. It's a change in viewpoint as to where we're going.
Now, when you talk about some of the ASHRAE standards that people know best, 90.1, energy efficiency is got to be on the top of the list. There are different, it's released. I think there's a number of releases that are improvements on the previous one. The last two being 2004 and 2007. I found it interesting, and when we talk about stimulus money that's being pushed forth, I know that there was a slide in your presentation that talked about where people are at now. But can you talk about a little bit about how the stimulus money is affecting what people are doing for energy standards?
Well, 90.1 was first developed in 1975, following the Arab oil embargo and energy crisis at that time. And that is a standard that is the fundamental basis of most of our energy codes in the United States. It's a standard that is on a constant development. We issue addendum to that standard on a regular basis. We also follow the code cycles, the building code cycles in terms of their updates. And so fundamentally, we revise Standard 90.1 and reissue it on a 3-year cycle basis. So you would have seen one in 2001 and in 2004, 2007, and we're upcoming now with the next issue, which is coming out in 2010. It's interesting that the Department of Energy required that all states it was the Energy Policy Act of 2005, EPAC 2005, that required all states to adopt ASHRAE Standard 90.1, 1999 or later. And yet, even today, there are many states that haven't got to that point. States have a great deal of independency from federal requirements, and so some of them have been much slower to update their building codes than others. But the building stimulus monies that have come out as a result of the economic crisis we have just been through are making a big difference. One of the requirements under the stimulus funding that goes to the states is that they update their building codes to be much more energy efficient, in fact to adopt not less than ASHRAE 90.1 2007. Every single state in the Union has accepted stimulus money. And so they now have an 8-year period of time to update their building codes and demonstrate 90% compliance as a result of that acceptance. So we expect to see a great deal of uniformity around the country as a result.
Now, when we talk about some of the newer standards that are similar to 90.1 but serve a different purpose, 189.1 is one of the newer standards that has just been released. Can you describe what 189.1 is?
Yes, this is a game changer in the industry. This is the world's first high-performance green building standard intended for code adoption. It is a comprehensive standard that addresses all aspects of building design, construction, and operation. So it's very unique in that regard. It's taken 3.5 years to develop. We issued it for publication at the very beginning of this year. But it addresses building siding, building orientation, building envelope design, insulation levels, even fenestration levels as they relate to daylighting. It addresses water conservation, which is becoming an even bigger issue today in the United States. It addresses indoor air quality, lighting systems, as well as energy systems. So it's a really comprehensive standard that actually mirrors much of the elements that you might see in the USGBC LEED rating system. And that's by design. USGBC has been our partner in developing that standard, so we work very closely together. They have recognized that in order to give the LEED rating system technical validity, they needed more sort of mandates behind that. And so the purpose of ASHRAE 189.1, amongst other things, is to provide the underlying guidelines and prerequisites for the LEED rating system. But there's a tremendous amount of interest out there in the different administrations and jurisdictions in the United States. We've actually had inquiries from probably about 1,400 code jurisdictions who are interested in adopting a green building code. So this has been a very, very important standard in development.
Now, you have just actually released information about something that's going on with the International Code Council, the ICC.
Yes, that's I think, been an exciting development. The International Code Council is the predominant code administration body in the United States. I think they service about 85 to maybe even as high as 90% of all code jurisdictions in the United States. And they were in the process of starting to develop the International Green Construction Code as a requirement for green buildings. And when they found out we were issuing Standard 189.1 and we found out they were developing the IGCC, we decided it was much more preferable for the industry for us to work collectively together. And so we have reached an agreement that'll be announced on March the 15th, that the IGCC, when it is issued, will contain Standard 189.1 in its totality as an informative appendix to the Green Code. But there will also be technical information from Standard 189.1 included inside the code, and 189.1 will be an alternative path of compliance, an option for code jurisdictions to use in adopting a green code in the United States.
Now, when we talk about energy efficiency, I know that 90.1 has been said is the code minimum. That should be, the least you could get away with if you're designing a building. That's the bare minimum. And most people think that that's an improvement, but it's really just a code minimum.
That is correct.
Of energy efficiency. What if you talk about 189.1? What kind of increase are you looking at as far as performance goes?
Well, energy is only one component of Standard 189.1, and it is meant to lead the industry. It is meant to be a higher standard, a high-performance standard. Our estimates are that Standard 189.1, as currently issued, is about 32% more energy efficient than Standard 90.1 2007. So it is the next step up. And our intent is to continue to improve Standard 189.1 as we move forward along a path towards net zero so that we hope that Standard 9.1 will provide net zero energy design guidance and requirements by the year 2030.
So all the 90.1, the 189, they're all kind of raising the bar as we go forward in years.
That is correct. And that's not only from the standpoint of good engineering practice and efficiency overall, but also responsive to new federal legislation that is coming down the track. The current acts that are going through the House and the Senate in our Congress, the Waxman-Markey Act, for example, would require all new commercial buildings and all new residential buildings to be 30% more energy efficient by the year 2010. That's right now, if that act passes. And be 50% more energy efficient by the year 2016. Those are aggressive targets, and we aim to be the society that provides that technical guidance to achieve those goals.
Now, for owners that have an existing building right now, I know ASHRAE has developed a building labeling program that kind of would allow them to see how their building's rated. And I guess how does the building labeling program kind of integrate into what most people, Energy Star is a big kind of rating system right now, and the LEED rating system. How do those three kind of compare?
Well, one of the fundamental goals of the ASHRAE Building Energy Labeling Program is just to provide building owners with an understanding of how their building is actually performing. I mean, it's very hard to improve what you're not measuring, and we don't have those measurements clearly available today. When you go and buy a car, you get a label on the side of the car that says 21 miles to the gallon city, 27 miles to the gallon highway. We aim to provide the same type of overall guidance in terms of energy performance as they relate to buildings. Now, there are differences between LEED on the one hand and Energy Star and the ASHRAE Building Energy Program. LEED is a point rating system. It is a rating system in terms of how the building is actually designed, but it does not provide specific numbers in terms of building performance, in terms that the building owner can necessarily understand. So whether we use terms like BTUs per square foot per year or kilowatt hours per square foot per year, that level of energy intensity use based upon actual metered data provides a direct input to the owner in terms of how their building is performing. But more importantly than that, we provide a comparison of that to similar buildings in the same climate zone. So it is a measure of comparison so that you know whether your building is performing well, maybe achieving an A level of performance, or performing poorly, maybe an E or A, maybe even an F in terms of performing. So it's a scale rating system that provides them a direct guidance in terms of actual performance. The difference, again, between that and Energy Star in itself is a rating that you get whether you are in the top 25 percentile performance of buildings in that particular field. But it does not give you the specific numbers in terms of actual energy intensity use that provides the owner with the guidance of comparison and the means to improve the performance of their buildings. So the background behind the labeling program also provides guidance in terms of step-by-step incremental changes the owner can make to improve building performance.
So you have, and as I understand it, there's kind of two different numbers, well, not numbers, but grades that you would get. You get one that is this is how the building was designed, and here's how the building is operating. That's correct.
It's a two-part label. The first label is, as you mentioned, the as design, and we call it the asset rating of the building. It is what the building is potentially capable of in terms of overall energy efficiency and performance. And then there's the reality, the actual in-operation rating, and that is based upon actual metered data. And so now you have a comparison between what the building is capable of on the one hand and what is actually performing on the other. And the background data and information that we provide as part of the labeling program is how to get back to what the overall goals and design intent was, how to improve the efficiency of the building to get to where you really need to be.
So what stage of the process is the labeling program at? Do you have test programs going on now?
Yes, actually we are in the pilot phase of the program. We rolled the program out in Louisville last summer. And in fact, we labeled the ASHRAE headquarters building as the first building in that program. We're now in the full pilot phase. We have worked with the real estate industry, with organizations like Hines and C.B. Richard Ellis. We've also worked with different city administrations, and we have chosen 25 buildings that range from about 25,000 square feet to as high as 750,000 square feet. And we're putting those buildings through the pilot program so we can flush out all of the issues in terms of data gathering, in terms of how information flows, in terms of the qualifications of energy auditors and assessors, all of those different issues, so that by the time we roll the program out fully to the industry, which will probably occur later in 2010, we know all the issues and parameters that we need.
Now, do you anticipate, and just knowing that it could happen like this, do you anticipate ever the asset assessment, the designed grade, is going to be lower than the building operating grade? I mean, could you envision that happening at all?
It would be wonderful if that did happen, but unfortunately that's not normally the circumstance. We have typically seen actual building performance significantly lower than design intent. Some of that is just due to incorrect sort of finalization and setting of the operations of the buildings and the systems. But part of it is just the occupancy of the buildings. The occupants have tremendous impact in terms of how efficiently the building actually works. If you look today at energy loads in buildings, we're making the envelope, we're making the building itself, we're making the lighting systems and the HVAC systems more and more efficient. What we have little control over is the actual use of that building in terms of the occupants, particularly in regard to data processing systems, laptop computers, and the like. If people will just leave their laptop computers running when they walk away from their workstation, that's a continuous load on the building, not only in terms of draw for the use of energy in the laptop, but also in terms of the heat release requiring cooling from the building systems. And so it's an educational process. We can put in occupancy sensors, we can put in demand control ventilation systems, we can do a lot of technology that will improve that, but it still comes down fundamentally to the recognition, to the fundamental understanding of the occupants of the building, of their part in this whole process. So we also aim to increase occupant awareness by providing sort of visual indicators in terms of energy use in buildings and the like.
It's kind of like a dashboard on their building automation system.
Absolutely. That's exactly what we're looking to do.
Now, I guess one of the components that I've seen is been a detriment to the the designed operation of a building is the operation, the maintenance staff, the people who actually operate, the building operators. What is ASHRAE doing to kind of help those people, understand the systems better? Or
that is actually fundamental. As much as the occupants are important, the operation and maintenance staff is really critical. If you look at the fundamental role of a building operator, you might think it is to make sure the systems are keep running efficiently and operating the way they were designed. That really is not the case. The fundamental role of a building operator really turns out to be to maintain occupant satisfaction. If he can reduce the number of complaints of the building occupants, I'm too hot, I'm too cold, it's drafty in here, and the like, then he's going to keep his building owner happy as well. And so when you do that, there's a tendency for the operators to sort of tweak the systems and to readjust the systems to try and sort of maintain that level of comfort. And pretty soon the building is no longer running the way it was intended. And so our goal is to provide training and education to building operators. We're developing training programs for that purpose. We're also raising the awareness of building owners. We're working with organizations like BOMA and IFMA to increase their understanding of the importance of well-trained building operators are if in the successful performance of their buildings.
Now, mentioning BOMA and IFMA, how are they, I guess, where are they in the whole process of this green movement?
Well, certainly I think there's a greater understanding and realization on their part that green and sustainable buildings do represent an increased value in the industry. If you ask them and ask their members what the real impact is, if they can demonstrate that that is a high-performing green building, it really puts a premium and value on that building of maybe 5 to 7% over and above other buildings, similar buildings around them. So that realization has already occurred. What we have to do as the next step is to get them to be prepared to invest in buildings so they can achieve that goal. And that's a change in philosophy. We are a very capital-driven society. We are a very first-cost-driven society. And we need to move that psyche from there to an overall realization that life cycle cost is much more important overall. And that's a change in some fundamental business practice and change in culture, if you like, that we need to go through.
Excellent. Well, I guess what can we expect from ASHRAE in the near future? What are some of the things that maybe haven't been released or that we can expect to see in the near future?
Just an expansion of all of the training tools and resources that we provide to the industry. We're providing new training programs and new certification programs on building commissioning as an important ongoing element in terms of system performance. We are certainly on a path towards net zero energy buildings, and so we're holding conferences around the globe, learning what is working better and what can be expected, learning what tools work correctly. You're going to see a much stronger interest in heat pump technology as a way to improve overall system performance and energy efficiency. So it's really a question of developing greater resources and tools and training for our members and for the industry overall.
Any closing thoughts that you have?
This has been a wonderful opportunity for me to serve as president of ASHRAE and to travel the globe and see what's going on. A tremendous learning experience and a tremendous opportunity to share my experience. And so I look forward to completing my term as president. I look forward to continuing to work with the society as we contribute to the overall good of our industry and aim for the overall sustainable future that we need.
Excellent. Well, thanks for taking the time to talk with us and about what you do and what ASHRAE is.
My pleasure indeed. Thank you.
All right. I hope everybody enjoyed the full interview with Gordon. I'd like to thank Gordon personally because it's been a real great pleasure to be able to talk with him for the time I did. And it was an ordeal. I mean, I'm relatively new at this, and you can tell. This is what we're now running on. This is the 10th episode. If we start at 0, work our way up to number 9. This is the 10th episode, and I had quite a bit of things that went wrong with this episode. I've actually tried to start it like 2 or 3 different times. When I was interviewing Gordon, I had batteries conk out. I use a digital recorder for the interviews. Most of the interviews that I've done through a digital recorder, and the batteries conked out. I had like a backup pair. I thought I had everything set up when I was interviewing Gordon, and it just did not work out, and I ended up scrounging around, going down to the hotel lobby where we were staying. They didn't have any batteries. I went to a nearby gas station. They didn't have any batteries. I ended up finally getting into the trunk of my car and remembering that I had a camera that I use for some of my commissioning work and flashlights. So I was able to scrounge together those. The one set of batteries that I put in there, nothing happened. My recorder didn't even turn on the second half. And finally, the last set of batteries I put in the digital recorder. Finally, those lasted the extra 45 minutes that I needed to finish off this interview. So, but it's not always easy doing what I do, but I just have to kind of share that with you because I thought it was rather humorous that to have the ASHRAE president there and go, hold on, wait a minute, I'm a dunce. I didn't bring enough sets of batteries, and that I have to kind of leave you for 15, 20 minutes while I go search, traipsing around trying to find some batteries that'll actually work. So I'd just like to thank everybody for listening. I really appreciate you, and I think we're doing some great things. We're going to have some great interviews coming up now and in the future. If you have any comments or want to give me some feedback, you can send that to me either at the blog at buildingx.co, or you can email me at matt@buildingx.co. If you want to follow me on Twitter, my handle is buildingx. And we're on iTunes, so if you heard us on there and you like the show, why don't you go ahead and leave me some feedback there. I'd greatly appreciate that. If you did enjoy the show, why don't you share it with a friend? Send an email, send a link, talk to them around the water cooler. Let them know that where we're at and how to listen to us. So, until next time, remember, know what you build, and share what you know.